The economic toll of tariffs between the US and China is no longer abstract. It is now materially impacting industries, prices, and supply chains. Yet, despite this tangible fallout, no credible signals of substantive negotiations have emerged from either side. Policymakers in both Washington and Beijing remain largely silent, offering no clarity or timeline for a diplomatic resolution. The absence of negotiation is striking, given the mounting strain on global commerce. Tariffs were initially framed as a temporary bargaining chip, but their prolonged use without dialogue has transformed them into a structural drag. US manufacturers are reporting increased input costs, while Chinese exporters face suppressed demand and contracting margins. Economically, both nations are absorbing shocks, but politically, the deadlock reflects a broader strategic disengagement. Analysts warn that the longer this vacuum persists, the more entrenched decoupling becomes, not just in trade, but in capital flows, tech standards, and geopolitical alignment. As trade routes shift and firms seek alternative hubs, the ripple effects are reshaping the foundations of globalization. The failure to reinitiate talks may no longer be a diplomatic lapse, but a deliberate strategic posture, signaling that both powers are preparing for a prolonged economic standoff with no clear off-ramp in sight. China is rapidly accelerating its investments in automation and artificial intelligence, transforming the backbone of its industrial economy. This is not merely a technological upgrade, it is a deliberate national strategy that is starting to tilt the global trade balance. By reducing its reliance on low-cost manual labor and replacing it with intelligent machinery, China is redefining its position in the global value chain. While Western economies often treat automation as a corporate initiative, China's centralized approach channels state funding, industrial policy, and infrastructure development toward a singular vision: technological self-sufficiency. This shift is enabling Chinese manufacturers to compete not just on price, but on productivity and scale. As this wave of automation gains momentum, its ripple effects are already being felt. Labor-intensive export economies, from Southeast Asia to Eastern Europe, are beginning to see competitive pressure from China's evolving industrial model. For the US and EU, this technological leap challenges traditional assumptions about comparative advantage and manufacturing dominance. From a macroeconomic standpoint, China's AI-driven manufacturing surge is not only enhancing its export resilience amid tariffs and geopolitical frictions, it is also laying the groundwork for long-term structural power in global trade. China is deploying a massive wave of industrial robots across its manufacturing base, what many are calling a robot army, to counteract rising labor costs and increase production efficiency. This strategic pivot is delivering a direct, unexpected blow to former President Donald Trump's tariff-based trade policy, which aimed to pressure Chinese exporters through cost inflation. Trump's assumption was that tariffs would make Chinese goods more expensive and less competitive. But by replacing human labor with robotics, China is offsetting those cost pressures, and in some cases, even enhancing its competitiveness. The automation surge has made production more agile and less vulnerable to wage fluctuations, allowing Chinese exporters to maintain pricing power despite punitive tariffs. This development has caught US policymakers off guard. It highlights a critical flaw in the tariff strategy. It underestimated the speed and scale at which China could technologically adapt. Moreover, it underscores how industrial policy and long-term planning, such as China's focus on smart manufacturing, can neutralize short-term trade weapons. From a broader perspective, China's robotic expansion signals a deeper strategic play, insulating its export machine from external shocks and asserting control over the terms of global manufacturing. Chinese factories are rapidly phasing out manual labor and transitioning to automated systems in an aggressive effort to insulate their production costs from US tariffs. By deploying robotics across sectors such as electronics, textiles, and consumer goods, manufacturers are softening the blow of import duties that would otherwise inflate product prices and weaken export competitiveness. This strategy is proving effective. Robotics-driven efficiency enables producers to maintain output levels and price stability despite external trade pressures. While US tariffs were designed to create cost-push inflation for Chinese exports, automation is acting as a shock absorber, preserving China's foothold in global markets. The broader implication is clear. Countries that automate faster are not just more productive, they're also more resilient to geopolitical and economic disruptions. China's manufacturing sector is evolving into a flexible, tech-enabled infrastructure less vulnerable to labor shortages, wage hikes, or policy shocks from abroad. From a strategic standpoint, this trend weakens the leverage of tariff-based pressure. It suggests that future trade confrontations will depend less on taxing goods and more on outpacing rivals in technology, productivity, and national industrial policy. While the United States leads in foundational AI research and cutting-edge robotics innovation, it continues to trail China in applying these technologies at scale within its manufacturing sector. Despite world-class labs and breakthrough prototypes, American factories have yet to embrace automation with the same breadth and urgency as their Chinese counterparts. The disparity lies not in technological capability, but in industrial implementation. China's state-driven push toward automation, bolstered by centralized policy, coordinated investment, and national goals like Made in China 2025, has accelerated real-world deployment of robots across even low-margin industries. In contrast, US adoption remains fragmented, often limited to high-tech niches or capital-intensive firms. This strategic gap has consequences. Without scaling automation across its industrial base, the US risks losing long-term productivity advantages and becoming more vulnerable to external shocks, including tariff retaliation and supply chain disruptions. It also weakens America's position in the emerging contest for global manufacturing leadership. Unless the US commits to a nationwide industrial modernization agenda, one that goes beyond innovation and into aggressive deployment, it may find itself outmaneuvered not only by China, but by other automation leaders like South Korea, Germany, and Japan. The Made in China 2025 initiative is not just a blueprint for technological advancement, it is the engine behind China's nationwide robotization. By aligning government subsidies, industrial policy, and strategic investment, Beijing has accelerated the integration of robotics even in less developed provinces that traditionally lag behind in automation. This strategy marks a clear departure from previous growth models. Instead of concentrating automation in coastal megacities, China is deploying robotic systems to inner and western regions, effectively redistributing industrial capacity while modernizing its economic base. Such moves not only reduce regional inequality, but also broaden the resilience of China's export apparatus. Analysts view this as a calculated effort to ensure that China's rise in high-tech manufacturing is not confined to elite zones. By embedding automation deeper into its national fabric, China aims to future-proof its supply chain network and reduce dependency on both foreign technology and urban labor pools. This decentralized robotization enhances China's strategic leverage in trade wars. Production is now faster, cheaper, and harder to disrupt across a wider geographic base, making tariff-based tactics less effective in the long term. Despite aggressive US tariffs aimed at eroding China's export dominance, Beijing has retained its competitive edge through relentless automation. By accelerating the deployment of robotics and AI across its manufacturing sector, China is not only absorbing tariff-induced cost pressures, but also outperforming emerging rivals like Vietnam and Turkey in both productivity and scale. Unlike lower-cost manufacturing hubs that rely heavily on cheap labor, China is increasingly competing on speed, precision, and resilience. Its automation strategy enables faster production cycles, consistent quality, and reduced exposure to wage volatility, factors that are difficult for labor-dependent economies to replicate. As multinational firms reassess their supply chains, many are discovering that China's high-tech infrastructure and automated consistency still outweigh the labor savings offered elsewhere. This has allowed China to maintain, and in some sectors, even expand, its share of global manufacturing despite punitive trade policies. Strategically, this positions China not just as a manufacturing powerhouse, but as an industrial innovator, able to outmaneuver tariff pressure through technology, not just cost-cutting. It's a signal to global markets. Automation is no longer optional. It's the new baseline for international competitiveness. China's automation push is reverberating most strongly across labor-intensive sectors such as electronics, home appliances, toys, and textiles. These industries, once heavily reliant on manual assembly lines and low-cost labor, are now being transformed by robotic precision and AI-enabled production systems. In electronics, robotic arms are now handling delicate component assembly at speeds far beyond human capacity, ensuring both consistency and scalability. In textile factories, automated sewing and cutting systems are replacing traditional garment workers, slashing production time while maintaining quality. Even in the toy sector, long considered immune to automation due to product variability, Chinese manufacturers are integrating robotics for molding, painting, and packaging. This sectoral shift is not just about cost, it's about control. Automation allows for faster lead times, lower defect rates, and tighter inventory cycles, making Chinese factories more responsive to global market demand. Moreover, it reduces reliance on volatile labor markets and strengthens China's grip on high-volume, export-driven manufacturing strategically. The transformation of these core sectors signals China's ambition to not only defend its dominance in traditional exports, but to elevate their technological intensity, blurring the line between low-tech and high-tech manufacturing. China is no longer treating industrial robotics as a tool for cost savings. It is leveraging automation as a dual-force advantage in both global trade and technological supremacy. What began as a response to rising wages and trade tensions has evolved into a long-term strategy to dominate the next generation of industrial innovation. By embedding robotics deep into its economic model, Beijing is positioning automation as a competitive moat. On the trade front, robots reduce exposure to tariffs and labor shocks. On the tech front, they serve as a foundation for broader AI integration, machine learning, and industrial data intelligence, capabilities critical for future geopolitical leverage. This strategic pivot signals a broader doctrine that future economic power will not be measured by labor force size, but by the speed and scale at which nations can deploy automation technologies. China's state-guided model accelerates this transformation, unifying capital, policy, and infrastructure around long-term industrial dominance. Geopolitically, China's robotics surge sends a clear message. The country is not just playing catch-up with the West. It intends to leapfrog in defining the industrial norms of the 21st century. This is no longer just about export resilience. It's about shaping the architecture of global technological power. The United States maintains a clear lead in artificial intelligence research and advanced robotics innovation. However, this advantage remains largely academic and experimental in nature, without a coordinated national strategy to scale automation across its industrial base. In contrast to China's state-led model, the US lacks a unified public-private framework to robotize domestic manufacturing at scale. Despite world-class institutions and billions in private capital flowing into frontier tech, US factories, especially in legacy sectors like textiles, consumer goods, and heavy machinery, remain under-automated. The result is a fragmented deployment landscape, where only large corporations in high-margin industries adopt robotics, while small and mid-sized firms fall behind. This absence of a national directive weakens America's long-term manufacturing resilience. Without scale-driven efficiency, US producers face rising labor costs, slow lead times, and greater exposure to global supply shocks. More critically, the lack of a robotics roadmap erodes the country's ability to compete with industrial strategies coming out of Beijing, Seoul, and Berlin. Experts argue that what the US needs is not more innovation, but coordinated execution, a national push similar to the CHIPS Act or the Inflation Reduction Act, dedicated specifically to scaling robotics in manufacturing. Until then, its AI strength risks becoming a theoretical edge with little industrial impact. China is steadily moving beyond its past image as a technology imitator and investing heavily in developing indigenous core technologies. This shift, from reverse engineering to original innovation, is transforming the nature of its rivalry with the United States. The US-China conflict is no longer just about intellectual property violations. It's now about who will define the standards and infrastructure of 21st century technology. At the heart of this transformation are government-backed efforts to localize production of semiconductors, industrial software, advanced robotics components, and AI frameworks. By reducing reliance on foreign inputs, especially in areas vulnerable to export controls, China aims to build a sovereign innovation ecosystem capable of competing on equal footing with Silicon Valley and its allies. This push toward autonomy changes the strategic calculus. The conflict is no longer reactive, punish copycats, but preemptive, contain independent innovators. US export restrictions on chips, AI, and advanced lithography are no longer just defensive tools. They're efforts to slow the rise of a technology peer. Analysts now warn that this is a full-fledged tech Cold War, where value chains are being redrawn not just for efficiency, but for control. China's success in core tech independence would signal a tipping point, one where global innovation no longer orbits exclusively around the West. China's industrial robot sector is expanding at a pace that now decisively outstrips the United States. Once focused primarily on domestic deployment, Chinese robotics firms are scaling production, improving quality, and entering global markets with increasing confidence. The country is no longer just importing robots, it's exporting them. According to the International Federation of Robotics, China already accounts for over half of global industrial robot installations. But what's more striking is the vertical integration. Domestic firms are now building key components, actuators, sensors, and control units that were once sourced from Japan, Germany, or the US. This development shifts China's robotics narrative from fast follower to potential global leader. Chinese robots are now competing in emerging markets, especially in Southeast Asia, Latin America, and parts of Europe, often undercutting Western rivals on price while offering improving reliability. Strategically, the rise of Chinese robotics exports marks a new front in the global tech-industrial rivalry. If China succeeds in scaling both quality and volume, it could soon become not only the world's largest user of robots, but also its dominant supplier. While the United States has focused its response to China's rise through tariffs and investment repatriation efforts, these measures remain reactive and fragmented. Washington has yet to match Beijing's highly coordinated, state-led industrial strategy, a model that integrates automation, innovation, infrastructure, and long-term capital deployment under a unified national agenda. Policies like the Inflation Reduction Act and CHIPS Act are important steps, but they lack the centralized execution and vertical integration found in initiatives such as Made in China 2025. Meanwhile, calls to reshore manufacturing have yielded modest results, often stalled by labor shortages, regulatory friction, and lack of automation capacity. In contrast, China's centralized planning allows for rapid scaling of new industrial clusters, especially in automation-heavy sectors. By aligning local governments, state-owned banks, and private manufacturers under one policy direction, China achieves cohesion that the US model, driven by market incentives and political fragmentation, struggles to replicate. Strategically, this imbalance in execution, not innovation, is where the US risks falling behind. Without a unified framework to drive large-scale industrial transformation, Washington's current approach may win headlines, but fails to build long-term manufacturing resilience. The global manufacturing paradigm is undergoing a structural transition, from labor-intensive models to robotics-driven production. What began as a strategic pivot in China is now a full-scale industrial transformation embraced by other economic powerhouses, including the European Union, Japan, and South Korea. The era of cheap labor as a competitive advantage is giving way to an era where automation, speed, and precision dictate manufacturing leadership. In Japan and South Korea, long-standing leaders in robotics, governments are accelerating integration of smart manufacturing systems across sectors ranging from automotive to electronics. The EU, through its Industry 4.0 framework, is heavily investing in AI-enabled factories to boost productivity and safeguard strategic autonomy. This global convergence signals a fundamental reordering of the supply chain logic. The traditional arbitrage of cheap labor is no longer sufficient. Instead, countries are racing to embed resilience, real-time flexibility, and intelligent systems into their manufacturing bases, making automation a baseline requirement rather than an upgrade. Strategically, the implications are profound. Those who lead in robotic deployment will command supply chain gravity, attract high-value production, and define the next wave of trade flows. This is no longer a regional trend, it is the new global manufacturing standard. Former President Donald Trump's tariff-centered strategy, once seen as a bold move to counterbalance China's manufacturing dominance, now appears increasingly outdated in the face of a global automation revolution. As industrial power shifts from cheap labor to smart machines, imposing taxes on imports is no longer sufficient to reshape trade flows or restore domestic competitiveness. The global manufacturing race is being redefined by robotics, AI integration, and state-led industrial transformation. While the US has excelled in innovation and research, it lacks a national policy to scale these technologies across its manufacturing heartland. This void leaves American factories vulnerable to rising costs, supply chain rigidity, and foreign competition operating at higher levels of automation. To remain globally relevant, the US must pivot from reactive protectionism to proactive modernization. Experts argue that a comprehensive federal robotics strategy, similar in ambition to the CHIPS Act, is urgently needed. Such a strategy should unite R&D, workforce retraining, infrastructure investment, and tax incentives to build a resilient and technology-driven industrial base. The future of economic power lies not in tariff wars, but in robotic capabilities. Without a national blueprint for automation, America risks not only losing its manufacturing edge, but ceding the very foundation of 21st century competitiveness.